In this video, we're going to continue having a look at solving trig equations. We've got 3 examples that we're going to work through here. So far, when we've been solving trig equations, they've always looked like this here. Sin x equals cos x equals tan x equals. But the problems you're going to encounter do not look like that. They're going to look a little bit different. What we essentially want to do though is we want to manipulate the original equations to get it into that form. We're essentially going to treat the equations just like how we would solve any equations. See, if this was the equation that we had to solve, we would add 3 to both sides and then divide through it by 5. The same is true for this equation here. Essentially, we're going to make sin x the subject of the formula. So we're going to add 3 to both sides. That's going to give us 5 sin x degrees is equal to 1. And then we're going to divide through it by 5. Doing that will make sin x the subject. Sin x is equal to a fifth. Okay, so we've just made sin x the subject to the formula. We're now going to go ahead, and this is like just where we were looking at our previous lessons. We're now going to proceed as normal with our cast diagram. So all sin, tan, cos, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. We'll have a look at our equation. Sin x is equal to 1/5. That is a positive number. So I'm going to take the 2 places where sin is positive. They're all positive here, and sin s is positive here. So I now know the 2 places where I'm going to tick. We're going to find our acute angle. We'll do inverse sine of a fifth. And typing that into our calculator, sine inverse of 1/5 is 11.5 degrees. So we've worked out our acute angle. We can then go ahead and work out our related angles. Remember, we're wanting to have 2 answers corresponding to the 2 quadrants that we've ticked. We ticked quadrant 1 and quadrant 2. In quadrant 1, our answer needs to lie in between 0 and 90. And 11.5 lies between those, so we're happy. In quadrant 2, our angle needs to lie in between 90 and 180. And 11.5 doesn't lie between those. So we're going to work back from 180. We're going to do 180 subtract 11.5. Okay, essentially I always say we work from the horizontal. When we do that, we're going to get 168.5 degrees. There we go. Okay, so all we had to do here is we need to do a wee bit of work first in order to make sin x the subject of the formula, which we achieved here. We then proceeded as normal by drawing our cast diagram, identifying where to tick, and then finding our related angles. That was example 1. We'll get 3 examples altogether. Example 2, we want to solve cos x plus 7 is equal to 6. We want cos x to be the subject of the formula. We'll subtract 7 from both sides. So we've got 8 cos x degrees is equal to -1. And then we'll divide throughout by 8 because we want cos x as the subject. We want cos x on its own. That's going to be -1/8. We've got cos x as the subject. Now that we've got that, we can draw a cast diagram. 0, 90, 180, 270, 360. We've got all sin, tan, cos, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Let's have a look at our equation. Here it is. Cos is equal to -1/8. Cos is a negative number. Where is cos negative? Well, cos is positive here and here, because they're all positive in quadrant 1 and cos is positive in quadrant 4. Therefore, if it's positive in 1 and 4, it's negative in quadrants 2 and in quadrants 3. Okay, we're going to find our acute angle now. Okay, so for the acute angle, we'll do cos inverse of 1/8. Remember, at this stage, we drop the negative. We use the negative to identify where to tick. But we drop the negative when we're finding the acute angle. That's 82.8 degrees. So that's what we're working with. And then we can now use that to work out our two related angles corresponding to the two quadrants that we have ticked. We ticked quadrant 2 and quadrant 3. In quadrant 2, the angle needs to lie in between 90 and 180, and 82 doesn't lie in between those. So we're going to work from the horizontal backwards. We're going to do 180 subtract 82.8. And then for the answer in quadrant 3, we're going to need to work from the horizontal forwards. We're going to do 180 plus 82.8. This here is going to be 262.8 degrees. This one here is going to be 97.2 degrees. I'm just going to double check that. 180 subtract 82.8, 97.2 degrees. There are our two solutions. Okay, so we change the subject to the formula to the trig function. We then draw our cast diagram. We tick what we need to tick, find our acute angle, find our related angles. Last example, example 3. We want to solve 4 tan x plus 5 is equal to 8. We want tan x to be the subject of the formula. Okay, so we need to subtract 5 from both sides. We're going to have 4 tan x degrees is equal to 3. And then we're going to divide throughout by 4. That's going to give tan x is equal to 3/4. We've now made tan the subject of the formula. We'll go ahead and draw our cast diagram, all sine, tan, cos, 0, 90, 180, 270, 360, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. If we have a look at our equation, tan x is 3/4, that's a positive number, so we need to tick where is tan positive. Well, they're all positive here, and tan is positive here, T stands for tan. So we'll go ahead and find our acute angle. We'll do inverse tan of 3/4. And that comes out to be 36.9 degrees. So we've found our acute angle, we can now proceed and find our related angles. We have angles in quadrant 1 and in quadrant 3. Let's have a look. In quadrant 1, the angle needs to lie in between 0 and 90. 36.9 lies between those. In quadrant 3, it needs to lie in between 180 and 270. Well, ours doesn't, so we need to work from the horizontal and we're going to work forwards from 180. So we're going to add our acute angle onto 180. 180 plus 36.9 degrees is going to give us 216.9 degrees. It's exactly the same as what we've been doing. All that's involved is this wee preliminary steps here to make the trig function the subject of the formula. Okay, so generally you start off, you make the trig function the subject of the formula, draw your cast diagram, tick where you need to tick, find your acute angle, and then your appropriate related angles. Hopefully that's made sense. Very examinable, comes up quite regularly in National 5 exams and prelims and past papers. Okay, thanks very much.